Hello, today is systems of inequalities. So we're going to be graphing and shading. If you do not have graph paper, you can do this by hand, or if you go on the internet and you have a printer, you can print free graph paper. I would highly suggest doing that. It's very helpful. All right, so now you should be on 5.4, systems of inequalities, and let's go. Okay, we're going to graph linear inequalities in two variables. We're going to graph nonlinear. We are going to solve using models or story problems and graph all the inequalities. So here we go. Let's just start with some reminders. If there's a less than or a greater than only, those are dashed lines on the graph. If it has a less than or equal to, so a line underneath, or a greater than or equal to, a line underneath, those are solid lines. You always test a point for true or false, and we shade true. So I shade the true section of the graph. Usually the point we pick is 0, 0, unless it is on the graph itself. All right, let's give this a shot. 4x plus 2y is greater than 10. I know generally we would solve this for y in graph, but I wanted to remind you of intercept graphing, just so we don't forget that these things exist. We can let x equal 0. So that would be 4 times 0 plus 2y is greater than 10. Well, then this term goes away. We would divide by 2, and y would be greater than 5. So what we really have here is a point. 0 for x, 5 for y, and we go 0, 5, and we put our dot, the y-intercept. Now the x-intercept, let y equal 0. So we do the same thing. We go 4x plus, I have no y's this time, so 0, oops, I did not write, is greater than 10, so this goes away. We divide by 4, so we have x is greater than 10 fourths or 5 halves, which is 2.5. So we go to 2.5 on my x, and we put that because this is the x-intercept, so it's 2.5 comma 0. We have two dots, and now we graph our line. It is greater than, so I know it's a dashed line. Okay, now I need to decide if I need to shade here or here. So what we do is we pick a point. I'm going to pick 0, 0 since it's not on the line, and we plug it into the original. So it's 4 times 0 plus 2 times 0 greater than 10. Is 0 greater than 10? This is false. That means this entire side of the graph is false, so we need to shade the true side, which would be over here. So all of these values are true. And shade it well. All right. Let's go on. Method 2 is we solve it for y equals mx plus b, so we get y by itself. So our first step here is to subtract the 4x. So we get y is greater than negative 4x plus 10, 2y, I'm sorry. Divide by 2, everybody. So y is greater than a negative 2x plus 5. So here we go to 5, we put our y-intercept. We go down 2 over 1. We graph in our line. Again, it's dash. You should get the exact same answer. We plug in 0, 0 back into the original. Again, this side is false, so we need to shade up here. And you can also do this with lines. I figured I'd show you both ways. So highlighting our lines both work. Okay, both methods are acceptable. I hope you pick the one that works best for you. Okay, pause and do this. Okay, I hope you did well. I chose to solve for y because I didn't like dividing by 3. So I subtracted the 3x, then I divided by 5, and I got y is less than or equal to a negative 3/5 x minus 2. So we go to negative 2 when we put our dot, because that's our y-intercept. We go down 3 over 5 to our second dot. It was an equal to, so you had a solid line. This time I picked 0, 0 again, and I plugged it into the original. So 0 plus 0 is less than or equal to negative 10. That's a false statement. 0 is greater than negative 10. So this is false. So this time we shade under the line. I hope you did a good job. Okay, nonlinear. 3x squared plus 1. You have to remember your parent graph. So remember, this is a parabola. The 1 means we start at 1. The 3 means we go up 3, left and right 1. And this time it's less than, so our parabola is dashed. Okay, if you don't remember, plug in your points, your -2, -1, 0, 1, 2. Now let's pick a point, 0, 0, and see if this is true. So a 0 greater than 3 times 0 plus 1. So a 0 greater than 1. This is a false statement. Since this is outside my parabola, we're going to shade the true, which would be inside the parabola or the shape. I think those are kind of fun. Something a little different. All right, now it is your turn. Okay, I hope you recognize this. This is a circle because they're both squared. Remember HK? So this is so your center was always the opposite. So it was -2 plus 5. So we're going to go to -2, 5. That's the center of my circle. I know my radius is equal to the square root of 16, which is 4. So we go 4 in all directions. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Did I do that right? All right. Draw your circle. Oh man, I messed up. I forgot to put a greater than or equal to. Let's do a less than sign this time. Less than or equal to. So now when you plug in 0, 0, it's a little bit different. So let's do 0 plus 2 squared plus 0 minus 5 squared. Is that less than or equal to 16? Well, this is 2 squared, which is 4, plus -5 squared is 25. Is that less than or equal to 16? And this is a false statement. 29 is not less than 16. So that means the outside of the circle is false, and we are going to shade on the inside. I hope you did a good job. I hope you remembered your circles with your HKs. Okay, systems of inequalities. So we're going to graph both lines. You're going to graph one line in shade and then the second line in shade. Where they overlap is your answer. So let's look at this first one and let's solve for y. So -3y is greater than, let's subtract the x. Let's divide by our -3. Now remember, when you're dividing by -3, you have to flip this inequality. So y is now less than 1/3 x, I want to see my slope, -2. So we're going to go to -2, put our dot. We're going to go up 1 over 3, put our second dot. It's a less than only, so this is a dashed line. You really need to use a straight edge here, which I do not have, because where they intersect can be important. Okay, let's plug in 0, 0 here and here. So is 0 plus 0 greater than 6? Is 0 greater than 6? This is a false statement. So this side is false. So we're shading this side right here. All of this is shaded. And I'm going to put hash marks going this way so it's easier to see. Okay, now I'm going to do my second line in another color. Usually pretty helpful. So if you have two colors, I would suggest doing so. Okay, let's move down here if it will let me. I just lost my pen for some reason. There we go. All right, so now you want to do intercept graphing, or let's do intercept just for fun. We're going to let x equals 0. So if x is 0, so this guy goes away, we get 3y is greater than or equal to -6. So y is greater than or equal to -2. So I'm going to go to -2 on y and put my dot, same spot. Now I'm going to let y equal 0, so I'm finding my x-intercept. So this time the 3y goes away, and we get 2x is greater than or equal to -6. So x is greater than or equal to -3. So let's go to -3 and put our dot. It's a greater than or equal to this time, so this is a solid line. All right, like so. Okay, let's plug in 0, 0 to our original. Is 0 plus 0 greater than or equal to -6? The answer is yes, 0 is greater than -6. So this time, this side of the graph is true. So we're shading this way. All right, this part here where we have the blue and the red is the double shaded. So this is our solution set right here. I need you on the test to color that very dark so there's absolutely no question that you know where it is. Any points in there are your answers. So whatever we get, here we go. Oh, please don't do that. Okay, maybe. I think it's still recording, at least I hope it is. All right, so when you go through here and you're looking at your solution set, we're looking at where they double intersect. So when we go here, anything in this area would work. So I could say 7, 0 is a point. I could say 11, -4 is a point. All of those work in my solution set. So you just got to create one and pick 2 inside of there. So any of those are acceptable. You would have different answers than me. All right, we're going to do 2x plus 5. So now it's your turn. So pause and try this. Okay, I hope you did a good job. I took both of them and solved for y this time. So the 2x plus y is greater than 5. Subtracted your 2x. So your y-intercept was 5 with a slope of -2. So you went down 2 over 1. It was a greater than, so it's a dashed line. We plugged in 0, 0. So 0 plus 0 is greater than 5 is a false statement. So we're on the red one now. So it's false. So then we shaded above. Next, we did the same thing over here. We added the 3x and divided by 2. So now we started at 4. We went up 3 over 2. This time it was an equal to, so we had a solid line. Again, we plugged in 0, 0 to our original. So 0 plus 0, is that greater than 8? That's a false statement again. So it's shaded above. And your answer is this section up here where this double shades. So make sure that is very, very dark. So if I asked you to pick a point, you could do like 210, and that would be an awesome point, or anything that you see. 210 would be one, 6, 18 would be one. You could do a negative, -2, 14 would be one. So many options. But make sure it's in this double shaded area, and that's what would solve those solutions and make them true. Okay, last but not least is your story problem. Okay, and we need to know the latest guide. Whoops, I hate it when I do that. Sorry about that. Let's get back. Okay, which apply to both men and women, give healthy weight ranges rather than specific weights for your height. Now, if the X represents height in inches and Y is your weight in pounds, the healthy weight region can be modeled by the following system. So you need to plug this in. So we go here, and I'm gonna solve for Y, just because that's way easier than trying to divide by all this. So we're going to, oh, actually you should be doing this, I'm sorry. Okay, pause and try. Okay, you really need a straight edge to do this one, and I did not have one, so hopefully you did way better than me. So I took the blue one first, I solved for Y here. So we subtracted the 4.9, we divided by our negative, remembering to flip our sign. I forgot to do it over here. Okay, so when you do that, we got 4.9x is -165. I went by tens on both axes so I could get it on here. So I went down 165. Then I changed this to 49 over 10 since I was going by 10. So I could go up 49 or almost 50 over 10. Then you should be drawing a straight line, this is really far off. Now you're going to do the same thing here. You're going to subtract the 3.7x. You're going to divide by a negative, flip your inequality, Okay, now you're going to go down to negative 125. You're going to go up 3.7 over 10. Draw in your axis. This is terrible. All right, now once you do that, we're going to plug in our 0, 0. I forgot to do it on the blue one. You plug in 0, 0. 0 is not greater than 65, so we shade away from the origin. On the red one, you plug in 0 and 0, and it is less than 125, so that's true, so we shade there. This in-between section is how much you should weigh. So my height is on the x-axis. So if I am 5'6", I go to 5'6", and then I would go up to my height, my weight, which is way off of this, but I think that's because my line is drawn in wrong. I really wish I could do this again. Let's see if we can get this erased. Okay, let's try this. Oops, it's not erasing. Please use a straight edge. It's very important. So this guy should actually be going like so. Oh, this is still not very good. All right, more like that. Now, 5'6", I would go up and say I'd have to, the most I could weigh is 150 according to this one, which is also bad, down to whatever. So this is where my shading should be. Also, if you recognize, you really can have negative weight. So everything should be here and above. But that's for another conversation. All right, I hope you did well. Post questions, help each other out, and let's do great on this homework. Have a great day.